Start. Good afternoon. We will study now the rules of exponent from your first chapter. Now, already we have studied the how to rationalize the denominator. Now we see the rules about the exponent. Now suppose nth root of a is there. This sign is called as radical sign. Nth root of a is equal to a raised to 1 upon n. This is the rule. And other is here a is greater than 0, it is real number. A is greater than 0, that is real number. Then nth root of a is equal to a raised to 1 upon n. The one more rule is there, which we have to remember this. If a is greater than 0, that is real number, and m and n are integers, or where n is greater than 0, means a is greater than 0 is real number, m and n are integers, and n is greater than 0, then a raised to m upon n is equal to nth root of a raised to m. Means here we are written nth root of a is equal to a raised to 1 upon n, where a is greater than 0 real number, a is greater than 0 real number, m and n are integers, where n is greater than 0, then a raised to m upon n is equal to nth root of a raised to n. So these ideas or these rules of radicals we are going to use to solve the different examples. Now we see some examples about this. Now suppose 4 raised to 3 upon 2. Then this we can write as 4 raised to 3 raised to 1 half. Means here 4 raised to 3 upon 2 means 4 cube raised to 1 half. If suppose 9 raised to 2 raised to 1 half, or 9 raised to 5 upon 2, 9 raised to 5 upon 2, then we write this it as 9 raised to 5 raised to 1 half. Means the denominator, which is n, that is taken as 1 upon whatever number is there, and the numerator denominator will go to the bracket indices. In this way we can write, where we are using the rule, this a raised to m upon n is equal to nth root of a raised to m. This rule we are using here. Now we see the rules of exponent, which already we have studied in the 7th and 8th standard, or that we call as indices. So if a is greater than 0 is real number, if a is greater than 0 is a real number, and p and q are rational numbers, then we will write the laws of exponent. The first is a raised to p into a raised to q. Now here base is same, so indices are added, and already you have studied in the 8th standard. Now only these rules we are writing for real and rational numbers. So a raised to p multiplied by a raised to q. In multiplication, if the base is same, indices are added. This we have studied in the 8th standard and 7th standard. If the base is same, in multiplication indices are added. Now second, a raised to p upon a raised to q. Now here division is there. So in the division, the base is same, then indices are subtracted. So a raised to p minus q. In multiplication, the base is same, indices are added. In division, if the base is same, indices are subtracted. Means these rules are there. This multiplication and for division, the rule is there. If only that if the distance are, means if the base is same, then only the we can use these rules. If the base is same, then indices are added, and if the base is same, then indices are subtracted in case of the division. Now third is, that is called as power of power, a raised to p bracket raised to q. So a raised to pq means here the first index is for a raised to p and again bracket raised to q is there. Then it is called as power of power. So a in a raised to p into q. So this is third. Then one more rule is there. If a raised to 0, then it is 1. Means if the index is 0, then the value is 1. These all rules you have studied in the 7th and 8th standard. First rule is about the multiplication. If the base is same, indices are added. If the base is same, then in division indices are subtracted. And if the power of power means two indices are there, that two indices are multiplied, and then we are getting the final index, that is a raised to p upon q. So these rules already you have studied, that we use for solving the examples in this class, which is for rational numbers or real numbers. Now we see the examples based on this. Now first see 2 raised to 2 upon 3 multiplied by 2 raised to 1 upon 3. So here base is same and indices base is same, we are doing multiplication, so indices are added. So 2 raised to 2 upon 3 plus 1 upon 3. So 2 raised to, now here denominator is same, so denominator same, we don't want to make the denominators equal. 2 plus 1, that is 3 raised to 3, and 3 cancel, so 2 raised to 1, that is 2. So if the in multiplication, if the base is same, then indices are added. So we have used the rule a raised to p into a raised to q is equal to a raised to p plus q. This rule already you have studied, that rules we are using for now rational numbers. So this is the example which based on this multiplication rule where the indices are added because the base is same. Other thing already you have studied, that fraction, addition and all that. Now we will see the second example from here. The second example is 7 raised to 1 upon 5 upon 7 raised to 1 upon 3. 7 raised to 1 upon 5 upon 7 raised to 1 upon 3. Now here base is same, so indices are subtracted. So 7 raised to 1 upon 5 minus 1 upon 3. 7 raised to 1 upon 5 minus 1 upon 3. Because base is same, we are doing division, so indices are subtracted. So here 7. Now here we have to find out the LCM because denominators are not same. So LCM is 15. So here you have to multiply by 3 and here multiply by 5. So 3 ones are 3, 5 ones are 5, or you can say the cross multiplication we have done. 3 ones are 3, 5 ones are 5. Upon the equal denominator means LCM, we have find out that is 15. Now 7 raised to, these signs are different, so 5 minus 3 is 2, but that is the sign of greater integer, so minus 2 upon 15. So 7 raised to minus 2 upon 15 is the answer of this example, where base is same. In the base is same, in division the indices are subtracted. Now we see the next example from here. 13 raised to 1 upon 5 into 17 raised to 1 upon 5. Now for this we cannot use the multiplication is there but the base is not same. So we cannot use this rule where the indices are added, because for using that rule the base should be same. So we write this in the one bracket 13 into 17, but here their indices is common, so that indices will come to the both same 13 into 17 raised to 1 upon 5. Here base is not same, but their indices is same, so that we are taken common. Now we multiply 17 3s are 51, carry 1, 17 1s are 17 and 5, that is 22, or 13 7s are 91, carry 9, 13 1s are 13 and 9, 22 raised to 1 upon 5. Means here we cannot use the rule because the base is not 10. So that rule is for indices only if the base is same, then only you can use that rule where the indices are subtracted or added. So when the base is not same, we have to use like this method where the index is same. We see the next example from here. 3 raised to 1 upon 5 raised to 4. Now in this example, here first index is 1 upon 5 and then 4. So here we are using the power of power, means we have to multiply by either this number to this or this number to this. That is called as power of power. So 3 raised to 1 upon 5 into 4, that we call as PQ. If A raised to P bracket raised to Q, then rule is A raised to P Q. It's A raised to P raised to Q. So this is called as power of power. So answer is A raised to PQ. So we are multiplying 1 upon 5 into 4. So that will come 3 raised to 4 upon 5. So in this way, we are using the rules for solving the examples. So the rules already we have studied, only we are applying this for. Now rational numbers we are applying these examples. Now we saw more example from your exercise 1.6. Now first is from third example. Exercise 1.6 third example. 2 raised to 2 upon 3 into 2 raised to 1 upon 5. 2 raised to 2 upon 3 into 2 raised to 1 upon 5. Now here multiply sign is not there. Instead of dot is given. Dot means multiply. Now here we can use the multiplication rule. Here base is same, so indices are added. So 2 raised to 2 upon 3 plus 1 upon 5. Base is same, in multiplication indices are added. Now again, the LCM of this 3 and 5 is 15. So here you have to multiply by 5 and here you have to multiply by 3. So 2 raised to, your LCM is 15. So here you have to multiply by 5 and here you have to multiply by 3. So 5 2s are 10 plus 3 1s are 3. So 2 raised to 13 upon 15. This is the answer of this example, as we are use the rule of multiplication. If the base is same, the indices are added. So here we added the 2 raised to 3 and 1 upon 5, which are indices. You are studying the fraction addition. The denominator is not same, so we have find out the LCM 15. Here you have to multiply by 5. 5 2s are 10. Here 5 3s are 15. So multiply by 3. 3 1s are 3. So 10 plus 3, that is 13 upon 15. So 2 raised to 13 upon 15 is the answer of this example. We will see next. 1 upon 3 raised to 3 bracket raised to 7. 1 upon 3 raised to 3 bracket raised to 7. Now this is the rule of A raised to P bracket raised to Q, because here index is there and here index is there. Now this index is common to the both numerator and denominator. So here index is 1, so 1 into 7 upon 3 raised to 3 into 7, because this index is common to both numerator and denominator. So 1 raised to 7 1s are 7 upon 3 raised to 7 3s are 21. But 1 raised to any index is 1 only. So 1 upon 3 raised to 21. So answer of this, now we have used the rule power of power, a raised to p bracket raised to q is equal to a raised to pq. So this 1 raised to 1 into 7 index is not there, so 1 into 7, here index is there 3 into 7, so 1 raised to 7 upon 3 raised to 10, 21, and 1 raised to any number, whether 5, 6, 100, anything, the answer is 1 only, and 3 raised to 21. So by using the power of power or exponent power, we have solved this example. Next we'll see from this same exercise, exercise 3.2, 11 raised to 1 upon 2 upon 11 raised to 1 upon 4. Now here you can realize or you can understand the base is same and we are doing the division. So if base is same and we are doing the division, then indices are subtracted. So 11 raised to 1 upon 2 minus 1 upon 4. Indices are subtracted, so 1 upon 2 minus 1 upon 4. Now here denominators are not same, so you have to find out the LCM. Now LCM of 2 and 4 is 4, or you can take also 8 as, but it is better to take 4. So suppose you can take the 8. So is equal to 11 raised to, your LCM is 8. So here you have to multiply by 2 4 the 8 and here 4 2 the 8. So 4 1 the 4 minus 2 1 the 2. So 11 raised to 4 minus 2, that is 2 upon 8, and 2 upon 8, here 4 1 the 4, 2 1 the 2, 4 minus 2 upon 8. So 11 raised to 2 upon 8, here we can cancel 2 1 the 2, 2 4 the 8. So answer will come 11 raised to 1 upon 4. Now here we have used the rule of division because we are doing the division, and in division indices are subtracted. So 1 half minus 1 upon 4. Now LCM of 2 and 4 is 8. So here to make the 8 in denominator we have multiplied by 4, and to make the denominator here 8 we have multiplied by 2. So 4 1 the 4, 2 1 the 2, 4 minus 2, that is 2 upon 8, and 2 upon 8 is not, we can reduce the fraction, 2 1 the 2, 2 4 the 8. So answer will come 11 raised to 1 upon 4. So in this way we are solving the examples which is based on the indices, only it is for the rational numbers. In last year you are using only whole numbers. Now 7 raised to 1 half multiplied by 8 raised to 3 upon 8 raised to 1 half. 7 raised to 1 half, dot is there, means multiply 8 raised to 1 half. Now here multiplication is there but base is not same, so we cannot use that rule. So this index is common to both, so that we have to take as the common. So is equal to 7 into 8 raised to 1 half, because this index is common to both, that we have taken as the common. So 7 into 8, that is 56 raised to 1 half. So if the base is not same, if the index are common, then that index will be taken common for that both the numbers, and then we can multiply or divide, and what is the common index that we have to give for the answer. So here answer is 56 raised to 1 upon 2. So in this way we are using the same rules which we have studied in the last year, only we are using for this real number or rational numbers. Next we'll see from exercise 1.6. First example, now we have to simplify, that is first is 64 raised to 1 half. 64 raised to 1 half. Now this we have to solve. So we have studied the rule that nth root of a is equal to a raised to 1 upon n. So this we have studied. Now this we have to use. So we are doing the square root of 1 half means square root. So instead of 2 you can change and we can write root 64. And you are knowing the square root of 64 is 8. So 64 raised to 1 half is nothing but 8. or if you are knowing the complete square of every number, that method also we can use. We can solve by this method like this. The 64, now here 2 is there, so we have to find out of which number 64 is square. So if you are knowing the squares up to 30, the 64 is the square of 8. So 8 square raised to 1 half, and then 8 raised to 2 multiplied by 1 half, that is 2 cancel. So answer will come 8. Means index is 1 half, means nothing but it is square root, and square root of 64 is 8. Suppose you are knowing of which number it is square is there. So 64 is the square of 8 raised to 2, or 8 square is 64 raised to 1 half. So this is, we are using power of power, 2 into 1 half, that is 2 cancel, and 8 raised to 1, that is 8. So by both the methods we can solve this example. Now next we will see 32 raised to 1 upon 5. 32 raised to 1 upon 5. Now we can write this. Now in the last example it was 2, so that we have taken the square root. Now we can write as fifth root of 32. Means we have to find out the fifth root of 32. Now fifth root of 32 we have to find out. So we can make the factors of this. Now you are knowing how to find out the factors. Now here 2 is there. So 2 16 the 32, 2 8 the 16, 2 4 the 8, 2 2 the 4, and 2 1 the 2. Now you see 1 2 3 4 5, the number is same. So how many times we multiply? 5 times if we multiply, then answer is coming 32. So fifth root of 32 is 2. So in this way you can solve. Or if you are good in multiplication, then you can find out the such number whose 5 times the number should be same, whose multiplication for 5 times is 32. That is also 2, and so fifth root of 32 is 2. So it is the easy method to find out the 1 upon fifth or 1/3, whatever number is given. You can use this method of prime factorization and you can find out the fifth root of 32, that is 2. Now one more we see from here, that is little bit difficult one is there. 125 raised to minus 1 upon 3. Now 125 raised to minus 1 upon 3, meaning in short you have to find out the cube root, because here 3 is there. So cube root of 125, but here it is negative sign. So cube root, you have, if you are knowing the multiplication properly, the same number you have to use. So cube root of 125 is 5, because 5 5 are 25, 25 is 125. You are knowing 5 cube is 5 into 5 into 5. So 5 5 are 25, so 25 5 are 125. So cube root of 125 is 5. So this you have find out. Now is equal to 125, means it is nothing but 5 raised to 3, and 5 raised to 3, that is raised to minus 1 upon 3. So these 3 will cancel and it will become 5 raised to minus 1. But according to our indices rule, we never keep the index negative. So when we take it to the denominator, it will become positive. So answer is 1 upon 5. So this 125 raised to minus 1 upon 3, answer is 1 upon 5. Now how we have solved this? Either you can use this method. The cube root you have to find out. So 125 cube is, means cube root of 125 is 5. So we have written 5 raised to 3 raised to minus 1 upon 3. So 3 cancel. 5 raised to minus 1, that is 1 upon 5. Or you can find out suppose cube root. Cube root means you want the pair of 3. So cube root of 125 is 5. Then 5 raised to 3 raised to minus 1 upon 3. 5 raised to minus 1 comes, because this is power of power. So 3 into minus 1 upon 3 is minus 1. And negative index we are changing to the positive. So answer will come 1 upon 5. So in this way we can solve the examples based on the rational numbers by using the laws of exponent. One more thing. Now one more you see, that is the 4 raised to 3 upon 2, or 4 raised to 3 upon 2, we have to find out. So here 4 raised to 3 and bracket raised to 1 half. 4 raised to 3 and bracket raised to 1 half. Now we first solve 4 raised to 3. 4 raised to 3 means 4 into 4 into 4 raised to 1 half. Now 4 into 4, 4 for the 16, 16 for the 64. 64 raised to 1 half. And 1 half means square root. So you are knowing 64 square root is 8. So answer of this question means whatever we are taken the example, that answer is 8. So in this way we can use these rules which I studied for exponents, means for rational number. We can use this rule and we can solve the example based on these rational numbers. One more example we'll see, and then we'll learn this 4 raised to, suppose 729 raised to 1 half. Now 729 raised to 1 half means that is the square root of 7 to 9, and square root of 7 to 9 is, if you are knowing the squares, 1 square is 1, 2 square is 4, and otherwise you can find out the square root by using this prime factor method. So 3 to the 6 remainder 1, 3 4 the 12, 3 3 the 9, 3 8 the 24, 3 1 the 3, 3 27 the 81, 3 9 the 27, 3 3 the 9, and 3 1 the 3. So square root you have to find out. So take the group of 2 2. So this 3 into 3, that is 9, 9 into 3, that is 27. So square root of 7 to 9 is 27. So answer of this is 27. You can use the other method. If you are knowing the square of this, you can write 27 square raised to 1 half, and this 2 cancel. So answer is 27. So by any method you can use the rules of exponent and you can solve this. So today we have finished the examples which is based on the laws of exponent. I hope that you have understood all these things. Thank you.